Fourier-Grenoble on use cases with IRODS and CiGri at CIMENT.
Okay, thank you. It's okay? You hear me? Well, I'm Bruno Bzeznik. I'm the technical manager of the HPC center of the University of Grenoble. And as an introduction, I would like to say that we're using IRODS since 5 years, and it rocks. So here's the plan. We are going to introduce a bit what is CIMENT and what we provide to our users. The main part of my talk is about what we are doing with IRODS, of course. And then we'll try to talk about currently running applications, if we have time. Then, what is CIMENT? We're located in Grenoble, France. And we provide computing resources to researchers of every scientific field covered by our university. For that, so we have a main HPC platform with more than 3,000 cores. And this is a platform optimized for parallel computing, so with a low latency network, and a Scratch directory, which is driven by Lustre. Next, we have a data processing platform, which is complementary of this platform. It is not for parallel computing, but more for sequential computing, for analyzing data. And so this machine is more heterogeneous and continuously evolving. It has big local scratches on the nodes and a 10 gigabyte Ethernet network. Then we also have about 10 other smaller clusters which are federated, and they generally have NFS file systems as a storage. And every platforms, so about a dozen, share a common storage which is driven by IRODS, and which is holding about 1 petabyte today. Talking about scheduling, we have our own batch scheduler, which is WAR, which we develop also at Grenoble. It is deployed on every platform. It has a particularity of managing a special kind of jobs, which we call best effort. Those jobs may be killed every time whenever any other jobs needs the resources. It is useful to optimize the load of the computing center because we have holes in the scheduling, and those little jobs may fill the gaps. So now, how does IRODS work on the CIMENT platforms? First of all, we have 3 sites, distant sites. And every supercomputers are connected to local IROD resources on the site. And everything is interconnected by a dedicated 10 gigabyte Ethernet network. So those links are to the IROD servers, and those links to generally a gateway to the network of the supercomputer. I didn't say the name, but the HPC platform is called Froggy, and the data processing platform is called Luc. And Luc has the particularity of having local scratches that may be registered into IRODS, so that some data may be available to other platforms. We have about 3 to 5 servers on each site. there's a unique zone for all the servers, and each server is driving 2 RAID arrays. Now, the CiGri middleware. It's a way for some of our users to access to the federated resources of CIMENT. We call it a lightweight grid middleware, and I'm the main developer of this middleware. It focuses on a particular campaign, a particular type of campaign of jobs, which are embarrassingly parallel. It is optimized for managing millions of small independent jobs, okay? And it is also efficient, very efficient, to manage with the best effort type of jobs that I talked earlier. It's very simple. It's a centralized server that is communicating with the WAR clusters through RESTful APIs. A user defines a job campaign and puts some input data and eventually the code of its application into IRODS. Then, when the campaign is submitted, CiGri generates a lot of small jobs. And each job can start to collect, to get data from IRODS. Then, when the job finishes, they return results data into IRODS, and the user can start to gathering the results. Or the user can get the result data, for doing some post-processing on the Look platform. Okay, so about our configuration, we are still using IRODS 3 with a very simple authentication. And all the computing nodes are connected to an iServer from the same site, and the files are randomly distributed on all resources of the site. We are using WebDAV, but only for the very initial transfers or the very final stages, as all mainly the transfers are made inside the IRODS cloud. So, but we have a little load consideration to do, because here we can have hundreds of jobs running from hundreds of nodes. So, surprisingly, we don't have problems with the meta catalog. The ICAT server is not the overloaded part. We have the biggest problem we have is with small files, and you know that small files for IRODS are files that are less than 32 megabytes. That overload the proxy iServe. What I call the proxy iServe is just the targeted iServer of the nodes on a site. For big files, the problems are more conventional, simply overload of the disks. And under heavy load, we also encountered some random errors. So we are using a max connection option in the connect control config file, which is very useful to limit the connections to the iServers. But it's not sufficient as it may make failing the jobs. So we have to do some retries, and the retry option of the iGet or iPut command makes too much stress. So we created a wrapper to have an incremental delay on the retries. We can also limit the number of jobs. It's a CiGri feature. And we also have a special case for very small files, about a few kilobytes, using the Python library. I will talk about it later. For the small files problems, we envisioned different solutions. I'm not going to talk about the round-robin DNS, as we didn't tested it. We made some tests with IPVS, so load balancing with Linux IP virtual server. Here is a simple test of a lot of IGETs, simultaneous IGETs of 1 megabyte files. Here is the result without using IPVS. So one iServer is overloaded by the connections of all the nodes, the cluster nodes. And with IPVS, everything goes fine. The iCat load is a bit strange. Don't know why. Maybe some flushes or things like that into the SQL server. But it's OK. So this is a very good solution for us. The rate also is better. With big files, we couldn't make the test, so we did it. But everything is overloaded with or without IPVS, of course. This is a simple test with a little Python library to parallelize the transfers I get here, but also for the metadata creation. And so we can see that compared to a simple recursive I get on a big collection of very small files, started from 4 threads, the results are far better. So about this load consideration, for us the iCat is never overloaded in our case. Connect control is a nice feature, but we had to implement our own retry option. No, not a retry option, but just a wrapper. IPVS might be a solution for the iServer overload problem with small files, but it doesn't help with big files. And the Python API may be a solution to efficiently manage large sets of very small files. Now, a few words about some currently running applications. Before that, some numbers. You can see the number of jobs, CiGri jobs. We calculated from the last 5 months. We have about 43,000 transactions per day. I think it's not ridiculous. First application, the Whisper project has already been presented last year. Okay, thank you. And it is from Seismology. So they have, what is particular in this context is the volume of data that has been analyzed in one experiment. A lot of experiments were driven with each times 200 terabytes of data. It's very, we had load problems with, particularly with this application. You probably heard about the European probe that is currently around comet nucleus. And we are proud to say that CiGri with IRODS contributed to the preparation of space operations to compute orbits, optimal orbits around the comet for the CONSERT equipment that is installed on this comet and that is made in Grenoble too. Currently analyses are running for the results of this experiment. In ecology, we have some biologists that are studying morphological similarities between species. I'm going quick because I'm running out of time. And finally, in particle physics, CiGri and IRODS were involved in the computation of the mass of the Higgs boson. And currently, another kind of computation are running for this is the research of exotic particles in the ATLAS experiment. So, as a conclusion, I would say that IRODS is very satisfying for us. And whenever needed, we just have to add some new servers, and so we have more storage. CiGri and IRODS are very complementary. We have some stability issues under heavy load, but we can deal with them. We're used to this kind of problems. And we have a lot of scientific results since 2010. As the future works, we are planning to upgrade, of course. We have to find solutions for better reliability and control of the load, and maybe this could be by a better integration within CiGri with the checking of some events and the support for storage resources in our batch system, for example. Thank you. If you have any questions.
You saw in the picture that you have IRODS. Was it the same IROD zone in all the university, or did you have a separate IROD zone in each university?
Sorry.
One zone or multiple zones?
One zone. Only one zone. Everything in one zone. It's very simple. The IROD configuration is simple in our case. It's just the infrastructure that is maybe big.
Hi, I'm House Yu. I have a question about the Higgs boson experiment. Can you talk a little bit more about what role IRODS played in the calculation of the mass of the Higgs boson?
Maybe you should contact Catherine Biscara. I can talk to her because I'm not a physicist, and it's hard for me to say what has been done. But actually, there are some papers published about this.
You know,
And they don't directly talk about IRODS, but they say when they say that CiGri is an asset, you have to know that CiGri doesn't work without IRODS.
Do you know how much data was involved?
A lot, because she's the one of the biggest users we have, and I always have to ask her to clean the collections. So about 500 terabytes or something like that.
Thank you.